Picture yourself under a star-filled sky. The kind that makes you feel like the universe is whispering secrets just for you. The air is cool, the stars are sharp, and then... Wait, what's that? A strange, fleeting streak cuts across your view, unlike any comet or asteroid you've ever imagined. This is Oumuamua, the first interstellar visitor to crash our solar system's party, and it's about to turn everything you know about the cosmos upside down. Back on October 19th, 2017, a telescope in Hawaii spots this cosmic oddball, and suddenly, scientists are buzzing like kids on a sugar high. Is it a rock from another star system, or, dare you even think it, a spaceship from an alien civilization? Strap in, because you're about to embark on a mind-bending journey into the mystery of Oumuamua, and it's going to ignite your curiosity like a supernova. Let's transport you to that moment of discovery. You're on a windswept hill in Maui, the Pan-STARRS telescope humming quietly nearby, scanning the heavens for anything unusual. Astronomer Robert Warwick is sifting through data when he freezes. A faint, fast-moving dot appears on his screen, and it's not playing by the rules. This thing is moving at 196,000 miles per hour, way too fast to be tethered to the sun's gravity. You can feel the adrenaline spike as he realizes this isn't just another space rock. It's an interloper from interstellar space. Named Oumuamua, meaning scout or messenger in Hawaiian, this object is unlike anything in our cosmic neighborhood. You're standing at the edge of history, witnessing the first confirmed visitor from beyond our solar system, and the implications are staggering. Now, imagine you're in Warwick's shoes, your pulse racing as you plot Oumuamua's path. Its trajectory is downright bizarre, a hyperbolic curve that screams, "I don't belong here." Unlike asteroids that loop around the sun in predictable orbits, Oumuamua is just passing through, like a cosmic hitchhiker catching a ride through our system. You can almost hear the universe chuckling, as if it's saying, "Bet you didn't see this coming." The object's speed and path suggest it's been wandering the Milky Way for millions, maybe billions, of years. A silent traveler from a star system far beyond our reach. You're struck by the sheer scale of its journey, drifting through the icy void of space, brushing past countless stars before stumbling into our little corner of the galaxy. Let's throw in a bit of historical context to ground you. In 1610, Galileo pointed his crude telescope at Jupiter and discovered its moons, shattering the idea that Earth was the center of everything. Oumuamua's arrival feels like a 21st century version of that moment. A humbling reminder that the universe is full of surprises. Here's a quirky tidbit. When Oumuamua was first detected, some astronomers mistook it for a local comet, only to realize its speed and trajectory were all wrong. Picture the chaos in observatories, with scientists jokingly calling it the comet that ghosted us. You can almost smell the burnt coffee as they debated late into the night, trying to figure out what this thing really was. So, why does Oumuamua feel so otherworldly? For one, it's the first object we've ever confirmed as coming from outside our solar system. That alone makes your skin tingle, like you're touching a piece of the infinite. Its reddish surface, scorched by eons of cosmic radiation, tells a story of a journey spanning unimaginable distances. But here's where your imagination might run wild. What if this isn't just a rock? What if it's a probe, a beacon, or even a derelict spacecraft from a civilization long extinct? You're not alone in wondering. Harvard astronomer Avi Loeb has argued that the alien spaceship hypothesis isn't as far-fetched as it sounds. Sure, it's a long shot, but the idea makes you feel like you're starring in a sci-fi thriller. Let's lighten the mood for a second. If Oumuamua is an alien ship, it's got to be the most antisocial visitor ever. No hello, No landing at Area 51, just a quick flyby and it's gone. Thanks for the cosmic drive-by, Oumuamua, you might quip. But in all seriousness, its discovery flips a switch in your brain. You're suddenly aware that interstellar objects can reach us, carrying clues about distant stars and maybe even hints of life. Oumuamua's strangeness, its shape, its motion, its very existence, challenges everything you've learned about the cosmos. You're standing on the precipice of a question as old as humanity. Are we alone? Feel the weight of that question yet? When Oumuamua was spotted, telescopes worldwide swung into action. But time was against you. It was already speeding away, fading into the cosmic darkness. You can imagine the frustration, like chasing a shooting star that's already gone. Scientists had just weeks to study it, capturing its faint glow against a sea of stars. Here's a mind-blowing detail. Oumuamua was only about 800 meters long, smaller than a city block, yet it grabbed the world's attention like a galactic headliner. You feel a mix of awe and insignificance, knowing this tiny object traveled light years to graze our solar system. Now, let's stir up some academic debate. Oumuamua's discovery raises a thorny question. How do interstellar objects like this form? And what do they tell us about the universe? Is it a fragment of a shattered planet, a comet stripped of its ice, or something we've never even imagined? The arguments fly fast and furious, with no clear winner. You're left grappling with the possibilities. If Oumuamua is natural, it's a window into the cosmos's deep history. If it's artificial, it's a game changer for humanity's place in the universe. Either way, its fleeting visit is a cosmic wake-up call, urging you to look up and wonder what else is out there. Before we move on, let's hear from you. Is Oumuamua just a wandering rock? Or could it be an alien scout? Drop your thoughts in the comments, and let's unravel this mystery together. Hold on to that spark of curiosity, because Oumuamua's story is just beginning, and the next clue might just redefine everything you believe about the universe. You're adrift in the cosmic ocean, stars glittering like distant lighthouses. When Oumuamua rockets past, a shadowy streak defying every rule you thought the universe followed. This isn't some docile asteroid tracing a neat orbit around the sun. No. Oumuamua's path is a wild, hyperbolic arc, a cosmic middle finger to the orderly dance of our solar system. It's speeding through at 196,000 miles per hour, like a galactic drifter who wandered into the wrong neighborhood. You're left staring, jaw dropped, as astronomers scramble to decode its bizarre trajectory. What's propelling this interstellar interloper? And where did it come from? Let's dive into the strange orbit of Oumuamua and uncover why it's got the scientific world in a frenzy. Imagine you're in a bustling observatory, the air humming with the soft whir of computers and the faint scent of coffee. It's late October 2017, and you're hunched over data from the Pan-STARRS telescope in Hawaii. Suddenly, your screen lights up with an anomaly, a faint dot moving way too fast to belong here. You plot its path, and your heart skips a beat. Most objects in our solar system, from planets to comets, follow elliptical orbits, looping around the sun like cosmic clockwork. But Oumuamua? It's on a hyperbolic trajectory, a one-way slingshot through our system. You can almost feel the universe winking at you, as if it's saying, "Good luck figuring this one out." This thing came from the direction of Lyra, swung close to the sun, and is now bolting toward Pegasus, never to return. Let's zoom in on why this orbit is so baffling. You're used to space rocks that play nice, born from the same primordial cloud as our sun 4.6 billion years ago. But Oumuamua's path screams outsider. Its hyperbolic orbit means it's not bound by the sun's gravity. It's just passing through, a cosmic tourist with no plans to stay. You can picture it wandering the Milky Way for eons, untethered, before our sun's gravity gave it a gentle tug. The numbers are staggering. It entered our system at 26 kilometers per second relative to the sun, peaked at 88 kilometers per second near its closest approach, and is now speeding away. You're hit with a sense of wonder, imagining this tiny object drifting past alien stars, nebulae, and maybe even worlds we'll never know. To ground you, let's touch on some history. In the 1600s, Johannes Kepler revolutionized astronomy by showing that planets move in elliptical orbits, giving us a tidy model for our solar system. Oumuamua's discovery feels like a playful jab at Kepler's legacy, a reminder that the universe loves to throw curveballs. Here's a quirky detail. When astronomers first tracked Oumuamua, they noticed its trajectory was slightly off from what gravity alone would predict. It wasn't a huge deviation, but it was enough to spark whispers of something's not right. You can imagine scientists joking over late-night pizza. What if it's got a tiny alien engine we can't detect? That oddity became a puzzle piece in the Oumuamua mystery, fueling debates that still rage today. Why does this orbit matter? For starters, it proves that interstellar objects can reach us, carrying stories from distant star systems. You're holding a piece of the galaxy's history, maybe a fragment from a planet that died billions of years ago. Oumuamua's reddish surface, baked by cosmic rays, feels like a letter from the deep past, written in starlight. But here's where your imagination might kick into overdrive. What if this path isn't random? What if something, or someone, steered it our way? The idea sounds like it belongs in a Hollywood blockbuster. But the orbit's strangeness makes you wonder. Could Oumuamua be a probe, sent to scout our system? Harvard's Avi Loeb thinks it's a possibility worth exploring, and you can feel the excitement crackling through the scientific community. Let's toss in a bit of humor. If Oumuamua is an alien ship, it's got the worst sense of direction in the cosmos. Swing by Earth? Nah, I'm just gonna zoom past and ghost you. But in all seriousness, this orbit is a scientific treasure. You're wrestling with questions that challenge everything we know. Most hyperbolic orbits we've seen come from comets nudged by Jupiter. But Oumuamua's path is too extreme, too alien, to fit that mold. You can sense the tension as astronomers debate its origins. Some say it's a natural object, perhaps a shard from a star system in Lyra, while others wonder if its trajectory hints at something artificial. The argument is a cosmic tug-of-war, and you're right in the thick of it. Feel the mystery sinking in? Oumuamua's orbit isn't just a math problem. It's a glimpse into the unknown. You're picturing its lonely journey, a silent trek through the galaxy's dark expanse, passing stars we'll never visit. Its speed made it a nightmare to study. By the time telescopes locked on, it was already fading into the void. Here's a jaw-dropping detail. Oumuamua's velocity matched the Milky Way's local standard of rest, moving at about 59 kilometers per second relative to the galaxy's flow. It's like it was drifting with the cosmic current. A leaf in an interstellar river. You feel a mix of awe and insignificance, knowing this tiny object has seen more of the universe than humanity ever will. Now, let's spark some academic debate. Oumuamua's orbit raises a big question. What launched it from its home star system? Was it a cataclysmic event, like a planet getting torn apart, or a subtle gravitational kick from a star? Some argue it's a rare asteroid, others a comet-like object without the usual icy tail. The lack of agreement keeps you on edge, wondering if we're missing something crucial. If it's natural, it's a clue to how star systems evolve. If it's not, You're staring at a discovery that could rewrite human history. Your curiosity is probably burning brighter than a supernova. And Oumuamua's story is about to get even stranger. Its orbit is just the first clue. Next, we'll dig into its bizarre shape and what it might mean. For now, what do you think set Oumuamua on this wild path? A cosmic accident or something more deliberate? Share your thoughts in the comments, and let's chase this mystery deeper into the stars. You're glued to a telescope feed, the dim image of Oumuamua flickering like a ghost on your screen, and it hits you like a cosmic thunderbolt. This thing is weird. It's not a chunky asteroid or a glowing comet. It's a long, slender object, shaped like a cigar from some interstellar smoke shop, with a reddish glow that feels straight out of a sci-fi novel. Oumuamua's bizarre appearance sets it apart from every space rock you've ever studied. And you can't shake the tingling suspicion that it's more than just a rock. Is it a quirky piece of cosmic debris? Or could its shape be a clue to an alien design? Let's zoom in on Oumuamua's peculiar form and unravel why its oddball look has scientists, and maybe you, questioning the very fabric of the universe. Imagine you're in a high-tech astronomy lab, the air thick with the hum of computers and the faint buzz of excitement. It's November 2017, and Oumuamua is the hottest topic in science. You're poring over its light curve, the way its brightness shifts as it tumbles through space, and the data makes your jaw drop. Most asteroids are lumpy, like cosmic potatoes, or spherical from eons of collisions. Oumuamua, though? It's insanely elongated, possibly 800 meters long, but only about 80 meters wide, with a length-to-width ratio of at least 10.1. You can picture it spinning end over end, like a cosmic pencil twirling through the void. Its surface, a deep reddish brown, looks like it's been roasted by the radiation of countless stars. You're hit with a wave of awe, realizing this object is a stranger in our solar system, a visitor that doesn't belong. Let's unpack why this shape is so bizarre. You're used to asteroids shaped by chaos, cratered, irregular, worn down by the rough and tumble of space. Comets, on the other hand, are icy snowballs that sprout glowing tails near the sun. But Oumuamua fits neither mold. Its cigar-like form is a cosmic oddity, rare even among the millions of objects in our galaxy. You can almost hear astronomers muttering, "This can't be right," as they double-check their data. The reddish hue adds another layer of mystery, hinting at organic compounds or metals altered by billions of years of cosmic rays. You feel a chill, imagining this object as a relic from a distant star system, its surface etched with the story of its endless journey. For a bit of historical context, let's rewind to 1801, when Giuseppe Piazzi spotted Ceres, the first asteroid ever discovered. That find revealed a whole new class of objects, reshaping our view of the solar system. Oumuamua's discovery feels like a modern parallel. But on a galactic scale, it's the first interstellar object we've ever studied. Here's a quirky tidbit. Early on, some scientists jokingly called Oumuamua a space burrito because of its elongated shape. Who ordered the cosmic taco? You might chuckle, picturing a galactic drive-through. But that odd shape sparked serious debate, because natural processes rarely produce objects this extreme. You're left wondering, how does something like this even form? The shape matters because it challenges everything you know about space rocks. In our solar system, asteroids are sculpted by collisions, gravity, and erosion, resulting in rounded or irregular forms. Oumuamua's extreme elongation suggests a wild origin, maybe a fragment torn from a planet during a stellar close encounter, or a process we haven't yet imagined. You can almost feel its surface, rough and pitted from eons of cosmic travel, its reddish glow a testament to its ancient voyage. But here's where your imagination kicks into high gear. What if this shape isn't random? A long, slender object is oddly practical for a spacecraft, designed to minimize drag or maximize stability. You're suddenly picturing a sleek alien probe built to cruise the galaxy for millennia. And the thought sends a thrill down your spine. Let's lighten the mood. If Oumuamua is an alien ship, it's got the most no-frills design in the cosmos. Forget flying saucers. Give me a space stick. You might laugh. But in all seriousness, the shape is a scientific puzzle. Some, like Harvard's Avi Loeb, suggest it could resemble a light sail, a thin, elongated structure propelled by starlight. You can imagine the academic fireworks, with skeptics scoffing and others leaning in, intrigued. The reddish surface, similar to some Kuiper Belt objects, adds fuel to the debate. Is it a natural rock with a weird history, or something more? You're caught in a cosmic tug-of-war, and the stakes couldn't be higher. Feel the mystery gripping you? Oumuamua's shape isn't just odd, it's a challenge to our understanding of the universe. You're picturing it tumbling through space, its long axis catching starlight as it spins every 7.3 hours. Telescopes struggled to capture it, as it was too small and faint for direct imaging. Here's a mind-blowing detail. Its brightness varied by a factor of 10 as it rotated, confirming its extreme shape. You can almost hear the gasps in observatories as scientists realized this was no ordinary rock. At about 800 meters long, smaller than a city skyscraper, it's a tiny speck that sparked a global obsession. You feel a mix of wonder and frustration, knowing we had so little time to study it before it vanished into the cosmic night. Now, let's stir up some academic heat. Oumuamua's shape raises a big question. How could natural processes create something so extreme? Some suggest it's a shard from a shattered planet, stretched by tidal forces during a close stellar pass. Others propose it's a comet-like object, stripped of its ice by radiation. But the absence of a coma, the gaseous envelope typical of comets, throws that idea into question. You're stuck in a scientific standoff with no clear answers. If it's natural, it's a window into exotic processes in distant star systems. If it's artificial, it's the discovery of the century. You can feel the weight of that possibility, like a cosmic whisper urging you to keep searching. Your mind is probably racing, and Oumuamua's shape is just one piece of this interstellar riddle. Its orbit was strange, its form is stranger, and there's more to come. What does this bizarre shape tell us about the universe, or ourselves? You're standing at the edge of the unknown, peering into a cosmos full of surprises. For now, keep that curiosity burning. What do you think Oumuamua's shape means? A natural fluke or a sign of something more? Drop your thoughts in the comments, and let's dive deeper into this cosmic mystery. You're locked onto Oumuamua's path, watching it streak through the solar system like a cosmic bullet, when a chill runs down your spine. This interstellar drifter isn't just gliding along its wild, hyperbolic orbit. It's speeding up, defying the iron grip of gravity in a way that makes your brain do somersaults. Unlike any comet or asteroid you've studied, Oumuamua accelerates without the usual fireworks of a glowing tail or icy jets. You're staring at the data, pulse racing, as a question burns in your mind. What's pushing this thing? Is it some bizarre natural force? Or could it be a glimpse of technology from a civilization light years away? Let's plunge into the enigma of Oumuamua's unexplained acceleration and uncover why it's got the scientific world in a feverish debate. Picture yourself in a high-tech observatory, the air thick with the hum of computers and the faint scent of late-night coffee. It's November 2017, and Oumuamua is dominating every conversation. You're analyzing its trajectory, already bizarre with its hyperbolic curve, when you spot something that stops you cold. As Oumuamua moves away from the sun, it's not decelerating as much as gravity demands. It's picking up speed, like a car hitting the gas on a cosmic highway. You can almost feel the universe winking at you, slipping you a riddle wrapped in starlight. Astronomers call this non-gravitational acceleration, a polite way of saying, we're stumped. You're gripped by a mix of exhilaration and bewilderment, knowing this tiny object is breaking every rule in the book. Let's unpack why this acceleration is so mind-boggling. You're used to space objects playing by Newton's rules. Gravity pulls, objects obey, end of story. Comets, for instance, can get a speed boost near the sun as solar heat turns their ices into gas jets that act like natural thrusters. But Oumuamua? It's got no visible coma, no dusty tail, no sign of outgassing. You're staring at what looks like a dry, reddish rock, acting like a comet without the special effects. Its surface, scorched a deep red-brown by eons of cosmic rays, suggests any ice it once had is long gone. Yet it's accelerating, gaining a tiny but measurable push as it races out of our solar system. You can almost hear the universe giggling, daring you to solve this puzzle. For historical context, let's rewind to 1687, when Isaac Newton laid out his laws of motion, giving us a playbook for how things move in space. Oumuamua's acceleration feels like a cheeky challenge to Newton's legacy, a cosmic curveball that doesn't fit the mold. Here's a quirky tidbit. When scientists first noticed this speed boost, some jokingly speculated about an alien engine. Maybe it's running on interstellar espresso, you might chuckle, imagining a cosmic hot rod blazing through space. But that subtle acceleration sparked fierce debate, because it doesn't align with any known natural process. You're left wondering, is this a new type of space rock or something far stranger? This acceleration matters because it's a screaming clue that Oumuamua is no ordinary visitor. You're picturing its journey, a silent odyssey across the Milky Way, now punctuated by this mysterious push. The data shows a slight deviation from its predicted path, about 0.1% more speed than gravity alone would allow. It's a tiny number, but it's seismic, shaking the foundations of what you thought possible. Some scientists suggest radiation pressure, where sunlight pushes on the object like wind on a sail. But that requires Oumuamua to be incredibly thin and light, almost like a cosmic sheet of foil. You're suddenly imagining a light sail, a thin craft propelled by starlight, as proposed by Harvard's Avi Loeb. The idea feels like it's ripped from a sci-fi novel, and it sends a thrill through your veins. Let's lighten the mood. If Oumuamua is an alien ship, it's got the worst throttle control in the galaxy. Ease up, aliens. You're gonna miss the scenic route by Jupiter. But seriously, this acceleration is a scientific goldmine. You're wrestling with questions that push the limits of physics. One theory suggests trace amounts of hydrogen gas, invisible to our telescopes, could be venting from Oumuamua, acting like a weak rocket. Another proposes it's a porous iceberg of frozen hydrogen, a rare object formed in the cold depths of space. You can sense the academic sparks flying, with scientists debating whether this is a natural quirk or a sign of something artificial. The tension is palpable, and you're right in the middle of it. Feel the weight of this mystery? Oumuamua's acceleration isn't just a glitch. It's a challenge to everything you know about the cosmos. You're picturing it speeding away, a reddish speck fading into the galactic darkness, leaving a trail of unanswered questions. Here's a jaw-dropping detail. The acceleration was so subtle it took months of precise measurements from telescopes like Hubble to confirm. You can almost hear the groans of astronomers as Oumuamua slipped out of range, too faint to study further. At just 800 meters long, smaller than a city block, it's a tiny object that sparked a global obsession. You feel a mix of awe and frustration, knowing we had so little time to unravel this enigma. Now, let's stir up some academic heat. Oumuamua's acceleration raises a big question. What could cause this without visible outgassing? Some argue it's a natural object, perhaps a hydrogen-rich fragment that vents gas we can't detect. Others counter that its density and shape don't fit that model, and radiation pressure seems unlikely unless it's impossibly thin. The debate is a cosmic standoff with no clear resolution. If it's natural, it's a clue to exotic processes in distant star systems, maybe a new class of interstellar objects. If it's artificial, you're staring at the biggest discovery in human history. You can feel the stakes, like a cosmic dare to keep searching for answers. Your curiosity is probably burning brighter than a supernova, and Oumuamua's story is about to get even wilder. Its orbit was strange, its shape was bizarre, and now this acceleration adds another layer to the mystery. What's driving this cosmic wanderer? A natural quirk, or something more intentional? Share your thoughts in the comments, and let's chase this enigma deeper into the stars. You're gazing into the starry abyss, Oumuamua's faint reddish glow flickering in your imagination, when a wild idea grabs you. What if this isn't just a space rock? What if it's a spaceship, a probe, or a forgotten relic from an alien civilization? The thought feels like it's ripped from a sci-fi epic, but it's not just your mind playing tricks. Some of the world's sharpest scientists are seriously considering it. Oumuamua's bizarre shape, rogue orbit, and mysterious acceleration have ignited a bold hypothesis. Could this interstellar visitor be proof of extraterrestrial intelligence? You're standing at the edge of a cosmic mystery, pulse pounding, as you dive into the electrifying and divisive idea that Oumuamua might be more than meets the eye. Imagine you're in a packed lecture hall, the air buzzing with tension as astronomers debate Oumuamua's data in late 2017. You're sifting through its quirks. A cigar-shaped body, a hyperbolic trajectory, and that strange speed boost defying gravity's pull. Most scientists lean toward natural explanations, but one voice cuts through. Harvard's Avi Loeb, who dares to suggest Oumuamua could be an alien artifact. You can almost hear the room split, some scoffing, others leaning in, captivated. Loeb points to its anomalies, the extreme elongation, the lack of a comet-like tail, the subtle acceleration. You're swept up in a wave of wonder, picturing a sleek alien craft drifting through the Milky Way, perhaps sent to spy on our solar system. Let's unpack why this idea is so gripping. You're used to space rocks being just that, rocks shaped by cosmic collisions or erosion. But Oumuamua's features are a puzzle. Its elongated form, possibly 800 meters long, but only 80 meters wide, has a 10:101 ratio that screams efficiency, like a spacecraft designed to slip through space. You can visualize it tumbling, its reddish surface catching starlight as it spins every 7.3 hours. Then there's the acceleration, a tiny push that doesn't match any known natural process. You're hit with a thrilling possibility. Could this be a light sail, a thin craft propelled by starlight? It's a concept humans are exploring, and the thought of an alien version sends your imagination soaring. For historical context, let's flash back to 1960, when Project Ozma kicked off the search for extraterrestrial intelligence, SETI, scanning for alien radio signals. Oumuamua's discovery feels like a bold new chapter in that quest. Not a signal, but a physical object that might carry alien fingerprints. Here's a quirky tidbit. When Loeb floated the spaceship idea, some colleagues nicknamed Oumuamua Rama, after the alien ship in Arthur C. Clarke's novel Rendezvous with Rama. Looks like the aliens skipped the welcome party. You might laugh, picturing a cosmic VIP who didn't RSVP. But that playful nod highlights a serious point. Oumuamua's oddities make the alien hypothesis tough to dismiss outright. Why does this hypothesis hook you? It taps into humanity's oldest question. Are we alone? You're imagining Oumuamua as a derelict probe, launched by a civilization long gone, drifting for eons until it wandered into our system. Its reddish hue, likely from cosmic ray bombardment, hints at an ancient origin, perhaps billions of years old. But here's the wild part. Its acceleration could be explained by a light sail, a thin structure that catches stellar radiation like a cosmic kite. Humans are testing this with projects like Breakthrough Starshot, aiming to send tiny probes to nearby stars. You can almost see it. A metallic sheet, glinting as it rides starlight, built to explore the galaxy. The idea sends a jolt through you, blending science with cosmic possibility. Let's add some humor. If Oumuamua is an alien ship, it's the ultimate galactic wallflower, just breezing through, no hello, no landing. Nice flyby, aliens. Next time, stay for the cosmic barbecue. But in all seriousness, the spaceship hypothesis is a scientific lightning bolt. Loeb argues that Oumuamua's traits, its shape, orbit, and acceleration, align better with an artificial object than a natural one. He points to its dramatic brightness changes, suggesting a flat or elongated structure ideal for a light sail. You can feel the academic heat, with skeptics calling it a leap, while others argue it's a possibility we can't ignore. You're caught in the middle, balancing logic and awe. Feel the weight of this idea sinking in? Oumuamua's peculiarities aren't just quirks. They're a challenge to our view of the universe. You're picturing its lonely journey, a silent voyage across light years, perhaps carrying the legacy of a civilization we'll never know. Here's a staggering detail. If Oumuamua is artificial, it suggests our galaxy could be teeming with similar probes, drifting like cosmic messages in bottles. You can almost hear the hum of telescopes as scientists race to study it, only to watch it fade into the void. At just 800 meters long, smaller than a city block, it's a tiny object that's sparked a massive debate. You feel a mix of wonder and urgency, knowing we had so little time to probe its secrets. Now, let's stir up some academic fire. The alien hypothesis raises a core question. How do we tell a natural object from an artificial one without touching it? Some argue Oumuamua's traits could stem from exotic natural processes, like a hydrogen iceberg or a loose dust cloud. Others, like Loeb, counter that its unique combination of features leans toward artificiality. The debate is a cosmic standoff, with no easy answers. If it's natural, it's a clue to rare processes in distant star systems. If it's artificial, you're staring at the first evidence of extraterrestrial intelligence. You can feel the stakes, like a cosmic challenge to keep an open mind and keep searching. Your mind is probably buzzing with possibilities, and Oumuamua's story is far from over. Its orbit, shape, and acceleration have built a mystery that's hard to shake. Is it a cosmic fluke or a sign of something greater? Drop your thoughts in the comments, and let's dive deeper into this interstellar enigma. You're still buzzing from the tantalizing idea that Oumuamua might be an alien spaceship. But now it's time to pump the brakes and face the skeptical side of science. Most astronomers aren't ready to jump on the extraterrestrial bandwagon. They're betting this interstellar oddball is a natural object, just one that's weirdly unique. Its cigar-shaped form, rogue orbit, and unexplained acceleration have fueled wild speculation. But could there be a simpler explanation grounded in the physics we know? You're standing in the crossfire of a scientific debate, where cold logic clashes with cosmic curiosity. And it's time to explore why many insist Oumuamua is just a quirky piece of interstellar debris. Let's dive into the natural explanations and see if they can hold up under the universe's unforgiving spotlight. Imagine you're in a high-tech research lab, the air thick with the clatter of keyboards and the low hum of heated arguments. It's early 2018, and Oumuamua's data is still the talk of the town. But the alien hype is starting to fade. You're sifting through telescope readings, trying to pin down this cosmic enigma. Its elongated shape, reddish hue, and non-gravitational acceleration are bizarre, no doubt. But your colleagues are waving Occam's razor like a flag. They argue Oumuamua could be a rare asteroid, a comet without a tail, or a new type of object we've never seen. You can feel the pull of their reasoning, like a cosmic tether yanking you back to reality, urging you to find answers within the laws of physics. Let's unpack the leading natural theories. You know asteroids, rocky, lumpy leftovers from planetary formation, and comets, icy bodies that flare up with glowing tails near the sun. Oumuamua fits neither box, but scientists propose it could be a hybrid or a new class entirely. One idea is that it's a planetesimal fragment, a shard from a shattered planet in another star system, stretched into its cigar shape by tidal forces during a close stellar pass. You can picture it being pulled apart, like cosmic dough in the gravitational hands of a star. Its reddish surface, baked by billions of years of cosmic rays, supports this, matching the hue of some Kuiper belt objects in our solar system. You're struck by how this theory simplifies things. Yet it still struggles to explain Oumuamua's full weirdness. Another hypothesis paints Oumuamua as a dark comet, a comet-like object that's lost its ice to radiation, leaving no visible coma or tail. You're imagining it as a ghostly husk, venting trace amounts of gas we can't see, which could explain its mysterious acceleration. This fits with its non-gravitational push, as even invisible outgassing could act like a tiny thruster. For historical context, let's look back to 1807, when Heinrich Olbers discovered Vesta, a comet-like asteroid that blurred the lines between categories. Oumuamua feels like a modern version of that discovery, a reminder that nature loves to mess with our classifications. Here's a quirky tidbit. Some scientists dubbed Oumuamua a zombie comet, as if it's a dead comet still wandering the cosmos. Brains, or maybe just some rogue hydrogen. You might chuckle, picturing a cosmic undead rock shambling through space. Why does the natural explanation matter? It keeps you grounded in Occam's razor. The simplest answer is usually the best. You're picturing Oumuamua as a relic from a distant star system, perhaps flung out during a planet's destruction or a star's explosive death. Its reddish hue, likely from organic compounds or metals altered by cosmic radiation, feels like a postcard from the galaxy's deep past. The acceleration could stem from solar radiation pressure or trace gas emissions, even if we can't detect them. You can almost touch its rough, pitted surface, a testament to its eons-long journey through the Milky Way. But here's the catch. If it's natural, why is it so unlike anything we've seen? You're grappling with the idea that the universe might churn out rare oddities we're only now encountering. Let's add some humor. If Oumuamua is just a rock, it's the most dramatic rock in the galaxy, strutting through our solar system like it's auditioning for a cosmic Oscar. Behold, I'm the fanciest asteroid you'll ever meet. But seriously, The natural hypothesis is compelling because it doesn't need aliens to explain Oumuamua's quirks. Scientists point to its brightness variations, which confirm its elongated shape as evidence of a tumbling, rocky body. Theories like a porous hydrogen iceberg or a loosely bound dust cloud could explain its behavior without invoking extraterrestrial tech. You can sense the academic sparks, with researchers debating whether Oumuamua fits known physics or hints at new natural phenomena. You're right in the thick of it, balancing evidence against speculation. Feel the pull of skepticism? The natural explanation tugs you away from alien dreams, but it's not airtight. You're imagining Oumuamua's journey, a silent voyage across light years, perhaps born in the violent birth of a star system. Here's a wild detail. Some propose it could be a dust bunny of loosely aggregated particles, so fragile it barely holds together under starlight. You can almost see it crumbling, yet somehow enduring its cosmic trek. At just 800 meters long, smaller than a city skyscraper, it's a tiny object that sparked a global debate. You feel a mix of awe and frustration, knowing we had only weeks to study it before it vanished into the galactic night. Now, let's stir up some academic fire. The natural hypothesis raises a big question. Can known physics fully account for Oumuamua, or are we missing a key piece of the cosmic puzzle? Some argue it's a hydrogen-rich object, venting invisible gas to cause its acceleration. Others suggest radiation pressure on a thin, flat surface. But critics note these models require extreme conditions, like unusual porosity or composition, that push the limits of plausibility. You're caught in a scientific stalemate, where each explanation feels like a partial fit. If it's natural, Oumuamua reveals the diversity of interstellar objects. If it's not, you're back to the alien question, and the stakes are astronomical. Your curiosity is probably burning bright, and Oumuamua's story is far from resolved. Its orbit, shape, and acceleration have built a mystery that's hard to crack. Is it a natural oddity, or something more? Share your thoughts in the comments, and let's keep chasing this cosmic enigma. You're watching Oumuamua vanish into the cosmic night, its reddish glow fading like a distant memory, and a surge of wonder washes over you. This interstellar wanderer, with its bizarre shape and mysterious acceleration, has slipped beyond our reach, but its brief visit has left an indelible mark. It's not just a fleeting guest. It's a cosmic alarm clock, jolting you awake to the vast possibilities of the universe. What does Oumuamua's flyby mean for humanity's quest to find life beyond Earth? And how will it shape our future in space? You're standing at the edge of a new era, heart racing, as you explore how this enigmatic object redefines our vision of the cosmos and what lies ahead. Imagine you're in a cutting-edge observatory, the air buzzing with the soft whir of computers and the chatter of scientists in early 2018. You're staring at screens showing Oumuamua's fading signal, a bittersweet reminder of how quickly it slipped away. Its oddities, cigar-like form, hyperbolic orbit, and non-gravitational push, have sparked debates that ripple beyond astronomy, touching the core of humanity's place in the universe. You can feel the weight of its legacy, like a cosmic seed planted in your mind, urging you to prepare for the next visitor. Is Oumuamua a one-time fluke, or a sign that interstellar travelers are more common than we thought? You're gripped by a sense of urgency, knowing we need to be ready for whatever comes next. Let's dive into what Oumuamua means for the future of exploration. You're used to thinking of our solar system as a closed system, a cozy bubble of planets and asteroids orbiting the sun. But Oumuamua shatters that idea, proving that objects from other star systems can cross light years to reach us. You can picture a galaxy teeming with such wanderers, shards of planets, rogue comets, or even artificial probes drifting through the Milky Way's vast expanse. Oumuamua's reddish hue, scorched by cosmic rays over billions of years, hints at a universe filled with ancient travelers, each carrying clues about distant stars. You're imagining a future with advanced telescopes like the Vera C. Rubin Observatory, scanning the skies to catch these visitors before they slip away. For historical context, let's flash back to 1992, when the discovery of the first Kuiper Belt object beyond Pluto expanded our view of the solar system's outer reaches. Oumuamua's arrival feels like a galactic version of that moment. The first confirmed interstellar object pushing us to rethink our cosmic neighborhood. Here's a quirky tidbit. Some scientists estimate that an interstellar object like Oumuamua passes through our solar system about once a year. But we've only recently had the tech to spot them. Talk about being late to the cosmic guest list. You might laugh, picturing a galaxy full of uninvited visitors we've been ignoring. This realization is driving a push for better detection systems, like space-based telescopes or AI-driven sky surveys. Why does Oumuamua's visit matter? It's a spark, igniting a fire to advance our search for life and understanding of the cosmos. You're picturing its journey, a silent odyssey across the Milky Way, perhaps born in the chaos of a star system's birth or death. Its brief stay, just weeks before it faded from view, exposed our technological limits. Telescopes like Hubble struggled to track it, and we had no probes ready to give chase. You can almost taste the frustration, like missing a shooting star you weren't fast enough to catch. But it's also a call to action, pushing humanity to develop faster, smarter tools. Probes to intercept future visitors, or even light sails inspired by Oumuamua's possible design, aimed at nearby stars like Proxima Centauri. Let's add some humor. If Oumuamua was a cosmic tourist, it was the worst at leaving reviews. Zipped through, no souvenirs, 1-star rating. But in all seriousness, its visit has practical implications. It's forced scientists to refine models of interstellar objects, from planetesimal fragments to hydrogen icebergs. The acceleration, possibly from invisible gas or radiation pressure, highlights the need for better detection methods. You can sense the scientific wheels turning, with researchers debating how to prepare for the next visitor. Some propose a network of space-based telescopes. Others dream of fleets of tiny probes, ready to chase down the next Oumuamua. You're caught in a wave of excitement, envisioning a future where we're poised to catch every cosmic traveler. Feel the pull of this moment? Oumuamua's departure isn't the end. It's a beginning, a challenge to expand our reach. You're imagining a universe where interstellar objects are common, each a window into alien worlds. Here's a staggering detail. Calculations suggest thousands of such objects could be passing through our solar system at any given time. Most too faint to detect with current tech. You can almost hear the hum of future observatories scanning for these drifters. At just 800 meters long, smaller than a city skyscraper, Oumuamua was a tiny speck that shook the scientific world, reminding you how much we have yet to discover. You feel a mix of awe and resolve, ready to push humanity's boundaries. Now, let's stir up some academic fire. Oumuamua's visit raises a big question. How do we prepare for the next interstellar object, and what will it reveal? Some argue we should focus on natural explanations, hydrogen-rich objects or dust clouds, to understand galactic processes. Others, like Avi Loeb, urge us to keep an open mind about artificial origins, as dismissing them risks missing a breakthrough. The debate is a cosmic tug-of-war, balancing caution with curiosity. If Oumuamua is natural, it's a clue to the galaxy's diversity. If it's artificial, it's a call to ramp up our search for extraterrestrial intelligence. You can feel the stakes, like a cosmic dare to dream bigger and build bolder. Your curiosity is probably blazing, and Oumuamua's story is far from over. Its visit has left us with questions and a renewed drive to explore. What will the next interstellar visitor bring? Share your thoughts in the comments. And let's keep chasing the cosmic unknown. You're standing beneath a vast, starlit sky, the memory of Oumuamua's fleeting visit burning in your mind. And a deep question takes hold. What does this interstellar stranger mean for humanity's place in the cosmos? This cosmic wanderer, with its cigar-like shape, rogue orbit, and unexplained acceleration, has vanished into the galactic void. But it's left behind a spark that lights up your curiosity. Was it merely a rock, or a hint that we're not alone? You're gazing into the infinite unknown, feeling both tiny and boundlessly connected, as you reflect on our role in a universe teeming with mysteries. Let's wrap up Oumuamua's story with a profound look at what it means for us and why our drive to explore the stars is more crucial than ever. Imagine you're on a quiet hilltop, the night air cool and crisp, stars shimmering like a celestial tapestry above. Oumuamua is long gone, lost to the cosmic darkness by 2018. But its brief visit feels like a whisper from the universe itself. You're replaying its journey. A reddish, 800-meter-long object slicing through our solar system on a hyperbolic path, speeding up in ways that defy easy explanation. Whether it's a natural oddity, a fragment of a distant world, or just maybe an alien artifact, Oumuamua has jolted you awake. You can feel the cosmos nudging you, urging you to ask, are we alone? Are there others out there, exploring, watching, or drifting past in silence? It's a question that makes your heart race and your mind soar. Let's dive into what Oumuamua teaches us about our place in the universe. You're used to seeing Earth as the heart of your world, a fragile blue marble in a vast cosmic sea. Oumuamua's visit flips that perspective, reminding you that our solar system is just a speck in the Milky Way, one of billions of galaxies. You can picture this interstellar traveler, its reddish surface scarred by eons of cosmic rays, carrying tales from a star system light years away. Its tiny size, smaller than a city skyscraper, belies its massive impact, a fleeting guest that crossed unimaginable distances to graze our system. You're struck by a humbling truth. Humanity, with all our telescopes and tech, had only weeks to study it before it slipped away. The universe, it seems, doesn't wait for us to catch up. For historical context, let's rewind to 1969, when Apollo 11's moon landing showed humanity could step beyond Earth, a triumph of curiosity and courage. Oumuamua's discovery feels like a different kind of milestone, not a physical leap, but a mental one, forcing you to confront the vastness of the cosmos. Here's a quirky tidbit. Some astronomers dubbed Oumuamua the cosmic boomerang for its slingshot trajectory, only to realize it was never coming back. Guess it's more of a cosmic hit and run. You might laugh, picturing this shy visitor speeding off without a goodbye. That fleeting encounter has sparked a global push for better tools, from advanced telescopes to probes that can chase future visitors, ensuring we're ready next time. Why does this moment resonate? Oumuamua isn't just a scientific curiosity. It's a mirror, reflecting both our potential and our limits. You're imagining its journey, a silent odyssey across the Milky Way, perhaps born in the wreckage of a shattered planet or the chaos of a dying star. Its brief visit exposed our technological gaps. Telescopes like Hubble struggled to track it, and we had no probes ready to pursue. You can almost taste the frustration, like missing a meteor shower by seconds. But it's also a spark, igniting dreams of new missions, Fleets of tiny probes, light sails inspired by Oumuamua's possible design, or observatories scanning for the next interstellar guest. More than that, it stirs a deeper question. What's our purpose in this vast universe? You're grappling with the possibility that the galaxy might be alive with life, probes, or relics waiting to be found. Let's add some humor. If Oumuamua was an alien scout, it clearly wasn't impressed with our cosmic neighborhood. Earth? Been there, done that. No t-shirt. You might chuckle, imagining it racing off to more exciting stars. But seriously, Oumuamua's visit challenges you to think bigger. Whether it's a natural object, a hydrogen iceberg, a dust cloud, or a planetesimal shard, or something artificial, it's a reminder that the universe is full of surprises. You can sense the scientific wheels turning, with researchers debating how to prepare for the next visitor. Some push for space-based telescopes, others for AI-driven sky surveys. You're caught in a wave of possibility, envisioning a future where humanity is poised to meet the cosmos head-on. Feel the weight of this reflection? Oumuamua's story is about more than one object. It's about us, our curiosity, and our relentless drive to explore. You're picturing a galaxy buzzing with motion, where interstellar objects drift like cosmic messages in bottles. Here's a staggering detail. Some estimate that trillions of such objects could be scattered across the Milky Way, most too faint for our current tech to spot. You can almost hear the hum of future observatories, like the Vera C. Rubin, scanning for these drifters. Oumuamua's tiny size, just 800 meters long, makes its impact even more profound, a speck that's forced us to rethink our place in the cosmos. You feel a mix of awe and purpose, knowing our quest to understand the universe is just beginning. Now, let's stir up some academic fire. Oumuamua's legacy raises a profound question. What does it mean to be human in a universe that might hold other intelligences? Some argue we should focus on natural explanations to unravel the galaxy's mechanics, while others, like Avi Loeb, urge us to keep an open mind about artificial origins, lest we miss a breakthrough. The debate is a cosmic dance, blending skepticism with wonder. If Oumuamua is natural, it's a clue to the universe's diversity. If it's artificial, it's a call to redefine our existence. You can feel the stakes, like a cosmic invitation to keep asking questions, keep searching, and keep dreaming. Your curiosity is probably blazing brighter than ever, and Oumuamua's story leaves you with a challenge: to look up, to explore, to never stop wondering. What does this cosmic visitor mean to you? Is it a reminder of our smallness, or a spark for our greatest adventures? Share your thoughts in the comments, and let's keep chasing the mysteries of the universe together.